at pH. So you can see that phosphorus, calcium is not so available, whereas manganese and boron is at the widest part, is freely available. Now if we take the pH way up the other end of the scale to say 9, we can see here that now phosphorus and potassium is freely available, but some of our microelements like iron, copper and zinc are not. So if we can keep our pH here between 6 and 6.5, ideally at 6.3, you will note that this line here goes through virtually the widest points of all the bands. This means that those nutrients are freely available to the plant. Now, we could use a can of baked beans as an example. If you don't have a can opener, you can't get to the food in the can. The can opener is the key, and pH is the key to the plant's feeding in the nutrient solution. If it's too high or it's too low, certain elements are not available to the plant. Keep it at 6 to 6.5, ideally at 6.3, and you won't have any problems at all. Now, how do we measure the pH? Let's have a look at the pH meter. The pH meter consists of a digital display on the main housing, and connected to that is the pH probe. And with the pH probe, the first thing that you must do before you use it is take the cap off. And you will notice that inside the cap there is some water. Now the reason for this is that if our pH probe is allowed to dry out, it becomes useless. And at $60 or $70 for a new pH probe, they're certainly worth looking after. To take a reading of the pH, what we first must do is calibrate it. And we calibrate it in a known solution of 7 pH. And all we do is we pop the probe in the end there, and on this particular meter we use a screwdriver to adjust so that the meter is reading 7. Once we've done that, we take the probe out, shake off the excess water, give it a bit of a rinse, again shake off the excess, and pop it into a known solution of 4. So we adjust on the meter so that it's reading 4, and now we're ready to take a reading. So effectively what we've done is we've now set the meter up at 2 known points, one here at 4 and one here at 7. So we can be pretty sure that anything we read between these 2 points will be accurate. So why don't we have a look and see what the pH of Sydney water is today. Take the pH probe out, pop it in to the water, and it shows a pH of 7.1. Now what do we do if we want to change the pH level in the nutrient? Well, we'll use a simple lemon as an example. Now, a lemon has citric acid in it, and we all know citric acid, if we rub it on our skin, it's not going to burn and make horrible marks on us. It's a very, very soft form of acid. What we'll do is we'll drop a few drops in to the Sydney water, we'll give it a stir, and now you'll see our meter will drop all the way down to 4.5. So what we've done, we've been from 7.1 on the scale, and we've come all the way down to here at 4.5, just by using an acid. Now, if we want to take it up to the other end, what we've got to use is something more caustic. And for this example, we'll use some simple kitchen bleach. And again, just a couple of drops. Give it a stir. And now, as you can see, the meter has gone all the way up to 8.6. So we've gone from 4.5 all the way up here to 8.6. Now, your local hydroponic shop has off-the-shelf pH raise and lower solutions. If you're a commercial grower, you'll use phosphoric acid or potassium hydroxide. And if you are using these materials, make sure you follow the safety instructions. Always remember, keep your pH between 6 and 6.5. 6.3 is optimum for maximum plant performance.
Here's a few tips to maintain your hydroponic garden at its best. Always keep the gully flow rate between 1 liter and 1/2 liter. That's between 1 pint and 2 pints per minute. That's the same as growing in media where the roots only need to be moist. Regularly check your plants for insects or fungus, and if found, treat quickly to prevent further spread. Examine the roots regularly. If you find they smell, there may be a fungal problem, which will need treating. Too high a flow rate will drown the roots and allow fungal spores in, thereby starting disease. Your local hydroponic shop will carry a range of appropriate products to treat each problem. Remember to rinse out and clean the gullies between planting. Hygiene is a key element in a successful system. With home hydroponics, you can pick what you need for your family each day. You can grow virtually any kind of plant. Now look at this crop of fresh, clean celery. You can make use of sunny walls to grow strawberries or grow those old-style, tasty, traditional tomatoes. Look how strong and healthy these roots are. They're only moist, not wet. You must never drown them. And these flowers, once set, will become a truss of healthy tomatoes. Notice how strong the plant is. To help you achieve this, Grant will now take us through the next topic.
Perhaps the greatest tool available in hydroponics is the ability to increase or decrease the strength of the nutrient solution. Now, nutrient strength is measured in CF, and this means the conductivity factor. We use the CF scale for its simplicity. You may have heard of total dissolved salts, parts per million, or microsiemens. These are all other measurements used in hydroponics, and they are all related. CF is measured on a scale of 0 to 100, with the area between 5 and 40 being the most commonly used for plant growth. Lettuce, for instance, being a leafy crop, requires a lower conductivity factor, around 5 to 10 CF. Tomatoes, however, being a sturdier and thicker and harder plant, require higher conductivity of around about 30 CF. Our nutrient levels are easily measured with an electronic meter, such as this conductivity meter. This CF meter, when it is immersed in a nutrient solution, simply measures the electrical resistance between two electrodes, caused by the amount of dissolved salt in the water. The more salt, the higher the resistance, the higher the reading. Let me demonstrate. We'll start with pure distilled water, which contains no dissolved salts, and we'll simply add some table salt. Now, table salt is adequate for this demonstration, remembering our nutrients are simply salts. As we stir, we find that the CF meter is now reading 15. To increase nutrient strength, it's simply a matter of adding in more salt or nutrient. To decrease the solution strength, we simply add fresh water, which will then dilute the nutrient strength down or simply reduce the ratio of salt to water. Now comes the real hard part. Plants feed in two ways. They use CO2 from the air and they take up mineral salts from their roots. As a general rule, 25% of their food comes from their roots and 75% from the air. Now think for a moment. If you're growing in a greenhouse or an enclosed area and taking into consideration that 75% of the plant's food supply is coming from the air, you must understand why excellent ventilation is extremely important. And as a rule of thumb, at least a third of the entire greenhouse floor is essential in vents. In a grow room type environment, it is important to ensure adequate ventilation, normally by way of an exhaust fan, and this is around 15 to 20 air changes per hour. You can also inject CO2 to increase plant performance. Now, when plants feed through their root systems, they feed using a process called osmosis. Osmosis is the movement of dissolved salt from an area of low concentration to an area of high concentration through what is called a semi-permeable membrane. In the case of a plant's roots, it is the root wall and hairs which is the semi-permeable membrane. Here we have a picture of a plant's roots. If the nutrient solution outside the root wall is 10 CF and the strength inside the plant is, say, 50 CF, the higher salt level will pull the low salt concentration across the root wall and into the plant. The greater the differential in salt strength, the quicker the movement or feeding will happen, and vice versa. If there is a small difference in nutrient strength, and the feeding or movement of salts across the root wall will be slower. So you will normally find when the CF is low, such as for plants like lettuce, the growth will be quite quick, producing a lovely leafy plant. Whereas with a higher CF preferring plant, such as tomatoes, the growth will tend to be slower, producing a stockier, sturdier plant. If we were to grow lettuce on a higher CF, the result would be a leathery, stunted, tough-looking plant. However, with tomatoes, if they grow on a low CF, they tend to grow tall and spindly. So you see, by adjusting the CF, it gives you the ability to manipulate and to control the look, the thickness, and the shelf life of your plants. However, it is important not to overfeed. If, for instance, your nutrient solution was at a CF strength of 90, we would have a situation where there is now more salt in the nutrient than inside the plant. This will result in reverse osmosis. In reverse osmosis, the high salt in the nutrient solution will pull the salt out of the plant. Plants with reverse osmosis will eventually just wilt and die. Have you heard of the saying, killing your plants with kindness? You see that your plants look sick, so you add some fertilizer. The next day, they still look sick, so you add a little more fertilizer, and before you know it, your plants are dead. Reverse osmosis has happened. The soil became so salty with the extra fertilizer that it is built to a point where it pulls the salts out of the plant. Now, in hydroponics, if you come across this situation before it's too late, you'll be able to flush with fresh water to lower the salt strength quickly. Good commercial growers use this to their advantage by taking all into consideration. It's possible to work out the actual optimum strength the crop will perform at its best. As an example, tomatoes growing at their optimum CF, which can be anywhere around 22 to 35. The grower could be getting 10 to 12 trusses of fruit between the base of the plant and what we call the top wire. Another grower could run at a lower or weaker strength and get only 5 or 6 trusses between the base and the top wire. Now, in money terms, that's a difference of 40 to 50% in production with no other financial outlay. So it goes to show that it's worth taking the time to ensure you have optimum CF levels. And just when you thought you had it all figured out, your plants have one more trick they can play on you. Plants will choose to take either water or salt from the nutrient solution. And if you're not careful, you can run into big problems. For example, a large commercial lettuce system. Each plant can take up to 800 mils or just over 1 pint of water in any 24-hour period. Now, if you have 30,000 lettuce, that's around 24,000 litres or 6,400 gallons. That's a lot of water. Now, as the plants are rapidly taking up the water and they continue to take out more and more, the density of the salt is increasing. If it's allowed to continue without being corrected, reverse osmosis is going to happen. Another thing to watch is as the temperature rises, so does the nutrient strength. As the temperature increases, the nutrient strength will rise about 5% for each degree in Fahrenheit, or 2.2% for each degree in Celsius. Both these problems are easily solved with a simple float valve, such as a toilet system. This allows fresh water to be replenished to the tank as it's removed by the plants. Also, if you have a leak, a float valve will prevent your tank running dry and damaging your pump. When using any type of flood and drain system, it is important to watch the irrigation cycles, as increases in temperature and water loss related to heat will occur. If allowed to go unchecked, it will cause stress, especially under hot lights or in windy conditions. During breaks in irrigation cycles, at worst, plants can rapidly take all the water out of the tray or channel, leaving only salt, and eventually you'll have dead plants. With overly long times between cycles, you can easily damage and stress, resulting in lower yields, not to mention damaged roots, which will now allow disease in, such as Pythium and Rhizotonia. It's probably a good idea to begin with frequent irrigation cycles if using media systems to start, then increase the intervals as you see fit. By understanding the principles of CF, you will be able to avoid unnecessary problems and maintain maximum healthy growth.
We can't keep a garden looking as good as this unless we think about heat. The average temperature for a plant's root zone is 59 Fahrenheit, that's 15 Celsius. If the temperature is under this, certain nutrients cannot be taken up by the plant. Different plants have different temperatures.